So let's perhaps talk about each of these areas. First, deeplearning.ai. The basic question, how does a person interested in deep learning get started in the field?
DeepLearning.ai is working to create courses to help people break into AI. So my machine learning course that I taught through Stanford is one of the most popular courses on Coursera.
To this day, it's probably one of the courses, sort of, if I ask somebody, how did you get into machine learning, or how did you fall in love with machine learning, or would get you interested, it always goes back to Andrew Ng at some point. So you've influenced, the amount of people you've influenced is ridiculous. So for that, I'm sure I speak for a lot of people, say big thank you.
No, yeah, thank you. You know, I was once reading a news article on, I think it was Tech Review, and I'm going to mess up the statistic, but I remember reading an article that said something like 1/3 of all programmers are self-taught. I may have the number 1/3 wrong, maybe it was 2/3. But when I read that article, I thought, this doesn't make sense. Everyone is self-taught. So, because you teach yourself. I don't teach people. I just...
That's well put. So how does one get started in deep learning, and where does deeplearning.ai fit into that?
So the deep learning specialization offered by DeepLearning.ai is I think it was Coursera's top specialization. It might still be. So it's a very popular way for people to take that specialization to learn about everything from neural networks to how to tune a neural network, to what is a ConvNet, to what is a RNN or sequence model, or what is an attention model. And so the deep learning specialization steps everyone through those algorithms, so you deeply understand it and can implement it and use it, you know, for whatever application.
From the very beginning. So what would you say are the prerequisites for somebody to take the deep learning specialization in terms of maybe math or programming background?
Yeah, need to understand basic programming, since there are programming exercises in Python. And the math prereq is quite basic, so no calculus is needed. If you know calculus is great, you get better intuitions, but deliberately try to teach that specialization without requiring calculus. So I think high school math would be sufficient. If you know how to multiply two matrices, I think that's great.
So a little basic linear algebra is great.
Basic linear algebra, even very, very basic linear algebra in some programming. I think that people that have done the machine learning course will find the deep learning specialization a bit easier, but it's also possible to jump into the deep learning specialization directly, but it'll be a little bit harder, since we tend to, you know, go over faster concepts like how does gradient descent work and what is an objective function, which is covered more slowly in the machine learning course.
Could you briefly mention some of the key concepts in deep learning that students should learn, that you envision them learning in the first few months, in the first year or so?
So if you take the deep learning specialization, you learn the foundations of what is a neural network. How do you build up a neural network from a single logistic unit to a stack of layers to different activation functions. You learn how to train the neural networks. One thing I'm very proud of in that specialization is we go through a lot of practical know-how of how to actually make these things work. So what are the differences between different optimization algorithms? What do you do if the algorithm overfits? So how do you tell if the algorithm is overfitting? When do you collect more data? When should you not bother to collect more data? I find that even today, unfortunately, there are engineers that will spend 6 months trying to pursue a particular direction, such as collect more data, because we heard more data is valuable. But sometimes you could run some tests and could have figured out 6 months earlier that for this particular problem, collecting more data isn't going to cut it. So just don't spend 6 months collecting more data. Spend your time modifying the architecture or trying something else. So go through a lot of the practical know-how, so that when you take the deep learning specialization, you have those skills to be very efficient in how you build these networks.
So dive right in to play with the network, to train it, to do the inference on a particular data set, to build the intuition about it without building it up too big to where you spend, like you said, 6 months learning, building up your big project without building any intuition of a small aspect of the data that could already tell you everything you need to know about that data.
Yes, and also the systematic frameworks of thinking for how to go about building practical machine learning. Maybe to make an analogy, when we learn to code, we have to learn the syntax of some programming language, right? Be it Python or C++ or Octave or whatever. But the equally important, or maybe even more important part of coding is to understand how to string together these lines of code into coherent things. So, when should you put something in a function column? When should you not? How do you think about abstraction? So those frameworks are what makes a programmer efficient, even more than understanding the syntax. I remember when I was an undergrad at Carnegie Mellon, one of my friends would debug their code by first trying to compile it, and then it was C++ code. And then every line that is syntax error, they want to get rid of syntax errors as quickly as possible. So how do you do that? Well, they would delete every single line of code with a syntax error. So really efficient for getting rid of syntax errors, but horrible debugging errors. So I think, so we learn how to debug. And I think in machine learning, the way you debug a machine learning program is very different than the way you like do binary search or whatever, or use a debugger, trace through the code in traditional software engineering. So it's an evolving discipline, but I find that the people that are really good at debugging machine learning algorithms are easily 10x, maybe 100x faster at getting something to work. So,
and the basic process of debugging is, so the bug in this case, why isn't this thing learning, improving, sort of going into the questions of overfitting and all those kinds of things. Yeah. That's the logical space that the debugging is happening in with neural networks.
Yeah, often the question is, why doesn't it work yet? Or can I expect it to eventually work? Yeah. And what are the things I could try? Change the architecture, more data, more regularization, different optimization algorithm, different types of data. So to answer those questions systematically, so that you don't spend 6 months heading down the blind alley before someone comes and says, why should you spend 6 months doing this?
What concepts in deep learning do you think students struggle the most with? Or sort of is the biggest challenge for them once they get over that hill? It hooks them and it inspires them and they really get it.
Similar to learning mathematics, I think one of the challenges of deep learning is that there are a lot of concepts that build on top of each other. If you ask me what's hard about mathematics, I have a hard time pinpointing one thing. Is it addition, subtraction? Is it a carry? Is it multiplication? There's just a lot of stuff. I think one of the challenges of learning math and of learning certain technical fields is that there are a lot of concepts, and if you miss a concept, then you're kind of missing the prerequisite for something that comes later. So in the deep learning specialization, try to break down the concepts to maximize the odds of each component being understandable. So when you move on to the more advanced thing, we learn confidence. Hopefully you have enough intuitions from the earlier sections to then understand why we structure confidence in a certain way, and then eventually why we build RNNs on LSTMs or attention model in a certain way, building on top of the earlier concepts. Actually, I'm curious. You do a lot of teaching as well. Do you have a favorite? This is the hard concept moment in your teaching.
Well, I don't think anyone's ever turned the interview on me.
I'm glad to be first.
I think that's a really good question. Yeah, it's really hard to capture the moment when they struggle. I think you put it really eloquently. I do think there's moments that are like aha moments that really inspire people. I think for some reason reinforcement learning, especially deep reinforcement learning, is a really great way to really inspire people and get what the use of neural networks can do. Even though neural networks really are just a part of the DeepRL framework, it's a really nice way to paint the entirety of the picture of a neural network being able to learn from scratch, knowing nothing, and explore the world and pick up lessons. I find that a lot of the aha moments happen when you use DeepRL to teach people about neural networks, which is counterintuitive. I find like a lot of the inspired sort of fire in people's passion in people's eyes comes from the RL world. Do you find reinforcement learning to be a useful part of the teaching process or no?
I still teach reinforcement learning in one of my Stanford classes, and my PhD thesis was on reinforcement learning, so I clearly love the field. I find that if I'm trying to teach students the most useful techniques for them to use today, I end up shrinking the amount of time I talk about reinforcement learning.
Interesting.
It's not what's working today. Now, our work changes so fast. Maybe this will be totally different in a couple of years. But I think we need a couple more things for reinforcement learning to get there.
To actually get there, yeah.
One of my teams is looking to reinforcement learning for some robotic control tasks. So I see the applications, but if you look at it as a percentage of all of the impact of, the types of things we do, is at least today, outside of, playing video games, right, in the field of games, the scope. Actually, at NeurIPS, a bunch of us were standing around saying, hey, what's your best example of an actual deployed reinforcement learning application? And, among like senior machine learning researchers, right? And again, there are some emerging ones, but there are not that many great examples.